Can I get your attention, guys? Hope you guys had a good break. It's been a while since we met. I purposely give you the last week off because I know you guys got lots of other tests and things to focus on, plus some of you want to get away. We're covering quite a lot of lecture material today. All I'll do is ask you the same kind of questions and everything, but we have missed one review session in a sense, so we need to catch up a bit. Just as a reminder, your 8% assignment is due next Thursday, so at the start time of the review session, the next one, review session number 5. And that's all electronic submission, PDF file, no hard copies. Just submit it to Canvas. 1 week after that, so that's the 3rd of October, a Thursday, is going to be test number 2. Shh. Test number 2, and that's 33% of your grade. Okay, that's going to be covering lectures 8 through 14. Okay, that goes from today. HVAC is our first one that we're going to get into, and that goes through lecture 14, and that's construction project management. It also includes parts 3 and 4, the last 2 portions of the Building a Skyscraper documentary. Okay, so I promise you that you'll actually have 90 minutes this time, and I won't screw up like last time, and it won't cut you off and all of that mumbo jumbo. So I'll do my best to make sure it all works like a charm. Next week, I haven't designed your test yet, so next week, one of the things that I'll do first off is go over the structure of test 2, and I'll try to give you as much nudge, nudge, wink, wink kind of hints as I can to make sure you guys do better than you did on test 1, okay? If things fall over and you don't bounce back incredibly awesome on test 2, I will go back and revisit the mark for test 1. I'm not going to do that until I see how you guys have done on test 2, because I can't give you marks and then take them away. You guys will riot and kill me, so I'm not going to risk that. So, for the first time ever in this class, and it must be this lecture theater, the live stream is finally at last working. So I know a lot of you guys probably showed up because I kind of waved a finger at you and said, if you don't show up, you're going to lose marks. Well, just lo and behold, live stream is working today. Go figure. Hopefully it continues to do so, but I don't know. Let's see what happens next week. See if we get 2 in a row. I don't know. Okay, so without further ado, I got some discussion questions here. And so remember, this is UPI first off. Yeah, got to use your UPI so I can give you marks for attending and participating today. Let's go down to the game options. Randomized order of answers. Oh, yeah. Automatically, no. Okay, classic. Okay, so UPIs only, please. There's your PIN, 299358. Slowly coming in. Must be those people at home. A few more. Okay, I'm calling it. Oh, that's not even a UPI. All right, here we go. Okay, we got 8 questions. Again, lots of content that we're covering, so quite a few extra questions here. First question. Which one of the following sources of heat flow through a building envelope involves convection? Talked about a few: conduction, convection, radiation. So, solar radiation, air infiltration, temperature difference. None of these are correct. It's all fake news. Okay. Convection, okay? 3 different ways of heat flow: convection, conduction, and radiation. I've asked you about convection. Probably not going to be solar radiation, all right? So this is accidental air infiltration. Just so happens, a little side note, PhD student of mine, she was also my master's student years ago, now she's doing a PhD. We're looking at about 30 dwellings in Glen Innes, this area that's being redeveloped. And some of those dwellings are old dwellings, some of them are new that have Homestar ratings, so they're green buildings, and some are just new and built to the code. It's interesting that we're finding there's quite a bit of overheating in the new dwellings. Do any of you guys have a new house? Yeah? Maybe with an upper bedroom on the second or first floor in this country. Our place got reclad, and it's got jam-packed full of nice new insulation. Man, that sucker could heat up. So it's interesting because what we're finding is there's this narrative in this country about cold, damp housing. You would have heard it many, many times off the tongues of a politician. Man, it's just killing us. Our housing stock is killing us. So what's the solution? Is put massive layers of insulation, seal it all up, and what do we end up with? Overheating housing. And we're probably going to end up having to have a bunch of heat pumps in the summertime, which in New Zealand, I remember when I came here, I couldn't believe it that there was no air conditioning in the house. I was like, well, where's the air conditioning? It's like, oh, the radiator, you see that thing? Just plug it in the wall. I'm like, are you kidding? Totally un-American. I'm used to it now. But anyway, it's just a bit of ironic thing. So another thing that, as far as air infiltration, as we know, old houses are drafty, and we find the exact same thing in that case study in Glen Innes. But there's actually components of this accidental air infiltration that are helping these old houses not overheat and actually keep themselves a little bit more comfortable than the airtight, double-glazed, highly insulated new housing. So anyway, interesting stuff. I know you guys are all super jazzed about what I just said, so never mind. It's not on the test. Okay, number 2. Which all-water system can have fan coil units in the same room, heating, so one of them heating, the other one cooling? What kind of system can do that? I noticed they changed Kahoot, and the reading time is now longer. So 4-pipe, 2-pipe, bagpipe, none of these, all of these. I didn't show you my little slide last time. It's okay. 4-pipe, that's right. Ooh, a close second. 2-pipe, didn't know which way to go. Okay, I'll just go through that. That's not going to really show you a whole lot. Anyway, that was about that first question. Here is the slide on the second question. So again, it's a fairly simple system, all water. Okay, so you're conditioning water as a medium for transferring heat or cool through the building. If you have a 4-pipe, then you have supply and return of both hot and cold all the time. So if somebody over here loves it hot, they could crank it up, turn it hot, and somebody over here likes it cold, they could turn it on cooling mode simultaneously. So you have more control over your space. It's less efficient because then the whole building has to be ready at any point in time to be able to supply the cool and the warm. And so it is more energy intensive, less efficient, but it gives the users more comfort because they can control their temperature exactly how they like it. Swill. Okay, true, false. In a chilled water plant, a compressor turns warm return water from the air handling unit, AHU, into a high pressure vapor to be condensed in the condenser. I just didn't have room to say that. Is that a true statement or a false statement? So what does our compressor really do? I'm hoping for at least, don't give me a 50-50 split on this one, please. What the? Okay. Before I continue, I do this. Okay, here's my first hint to you, okay? This is important. this is something I could guarantee you will have a nice big fat essay question on your test, okay? You will be asked to try to understand and comprehend what the heck is going on in this the chilled water plant, all right? So I won't go over this diagram. I'm just going to zoom to the little more cartoonish one here. Both are cartoonish, but I'll go to this one. So obviously that's the compressor here, yeah? Same thing, this is zoomed out. Hey, here's our compressor. This loop right here that I'm tracking with the mouse is got refrigerant in it, refrigerant, not water. Okay, a lot of students think the whole thing's just got all kinds of different types of water. Okay, this is a closed loop of refrigerant. Unless there's a leak somewhere in the system, you should never have to refill. It's just recycling the same refrigerant over and over again. Okay, that's not the same and say this over here, that's water and it's open, you have to top it up because it evaporates. Okay, this is up at the cooling tower. So what's happening here in the heart of the chilled water plant is you have a compressor. The refrigerant at this stage is kind of a little bit spent. Okay, it's a gas and it's low pressure. So what does a compressor do? It turns it into high pressure, but it hasn't changed it from a gas. It is still a vapor. Okay, it's not a liquid just yet. So this side, low pressure vapor. This side, high pressure vapor. On this side of the diagram, it's all high pressure. On this side, it's all low pressure over here. So here we have a high pressure vapor. Okay, when it comes in contact with what's called condensing water, the whole point of these big, gigantic pieces of equipment on the roof, cooling towers, is to slightly lower the temperature of the condensing water just a little tiny bit, just cool enough so when it runs over and kind of that water cascades over a bunch of pipes containing a very high pressure vapor, it condenses that vapor refrigerant into a liquid high pressure. Yeah? So now this goes from a vapor to a liquid, all right? And all of that is important because once you get over to here, I'll just go back a slide, you go to where all the magic occurs, okay? If you guys have watched the lecture, you'll know this. Okay, there's a little fairy that lives in there, a little wand, and she goes pow every 3 seconds, okay? And she takes that refrigerant, and that refrigerant's busting to explode. It's high pressure, it's a liquid, it goes into an expansion valve, and the way it works, Boyle's law, is that liquid expands rapidly. And as it expands, it dissipates all its heat, and it goes really, really, really cold, okay? So that refrigerant went from being much warmer and a liquid to a very dispersed gas, and it's very, very cold. That is what enables, if you listen really carefully, this place would have AC coming through these ducts. All of that is the exact same wonder that little genie in there, or whatever it is she's doing, that's the magic, okay? That's what allows the air to be cooled. So here you have this really, really cold refrigerant now. It's a vapor. And we have to take that cool, okay? We need to grab that cool energy in a sense. And so we use chilled water. And I know this is where it gets a little bit confusing. It's like, oh, chilled water, that's the cool. No, really the cool comes from the refrigerant, okay? The water becomes chilled because it comes into contact with the super cold refrigerant, okay? Over here on the evaporator side. Okay, so as that water comes in, it's already been warmed up, it's been spent, it's already done its business up here. It then has a heat exchange, it picks up the cool, okay, it gives off heat to the vapor, okay, to that refrigerant, and by the time it makes it down here to the bottom, it is chilled water. It's pretty cold, all right? It's not frozen, but it's pretty cold, and it's cold enough for us to condition the air in our nice big buildings like, well, this one's not nice, but OGGB, you know, places that we care about, it cools down the air and it makes us more comfortable, okay? So there's all kinds of cycles going on, and this is what I'm gonna expect and demand from you in your test. You will have to go through and explain all of this stuff going on, what the hell these things are called, how they relate to one another. So I'm gonna spend a little bit of time right now going over it, okay? We don't have a test review, a special little session before test 2, so this is being recorded. You're gonna have a recording of this, take a bit of notes, okay? These are the things that I'm expecting you to kind of return to me on your test 2, okay? So I've just kind of explained how that refrigerant loop works, okay? So there's a bit of a heat exchange over here. That's condensing that refrigerant from a vapor to a liquid. Critical task. Have to do that in order for the magic to occur at that expansion valve, okay? So heat exchange here. Now, what's making that happen? Well, that's the condensing water, okay? So the condensing water is not chilled water, it's just condensing. It's not super cold, but it's cold enough to make that condensation occur within the pipes of refrigerant. Okay, so here it comes down fairly chill, or not, fairly cool condensing water. As it gets down to the bottom, it has warmed up. You can't just do it again and again and again. It doesn't have the right temperature anymore to be able to condense that refrigerant. So it has to be sent back up to the cooling tower where another heat exchange occurs. So up here at the top, that condensing water gets sprayed out. And if you guys watched the 3D, the VR tour, you would have seen me walk past these things, or you would have virtually walked past them on the computer. And that fine mist pattern of condensing water sprays out, and as it falls through this big box, largely void, it will exchange heat and give off heat to the atmosphere. A big fan is pulling air through, fresh air, and that water will change in temperature between the top of this box and the bottom down here. Change just enough in temperature to be able to, again, do the magic of condensing that refrigerant back into a liquid again and again. And these systems go on and on and on, and they all have to work, otherwise the whole thing doesn't work, and you won't have air conditioning coming out of your ductworks. Okay, so here's another heat exchange, On this side, I've already talked about this one, where the chilled water comes in, spent. It gets chilled by coming into contact with that really, really super cold refrigerant, which is a vapor at this stage over here. Okay, another heat exchange, all right? So here we have our chilled water. It goes to the air handling units. Okay, again, if you looked at that VR field trip, I walked past some big air handling units. We opened up so you can kind of see inside them a little bit. You saw the fan rotating in the background. Okay, there's a series of pipes, coiled pipes. That chilled water is flowed through those pipes. Okay, it's cold. The air that's going to come in is going to be warmer in cooling mode. The air comes in a bit warm. And again, heat is exchanged. So that chilled water picks up the heat from the air temperature drops. Simultaneously, that air, if it comes in with humidity, with moisture in it, it has to drop off the moisture, okay? Because the temperature, as the temperature drops, it can hold less moisture. So it has to give off some of the moisture in condensation, and you drain that away. So you're knocking down the temperature and you're bringing down the humidity, making it more comfortable for us. That's what we like. 50% humidity, awesome. And a nice, cool, say 20 degrees, 21 degrees is a nice indoor air temperature. Okay? And it filters, and I won't go through all of these things. You guys can watch the video again. But it's these heat exchanges and these loops, okay? Chilled water, condensing water, refrigerant. Knowing all of these terms and how these things relate to one another and what they do, this is going to be a massive essay, okay? This is going to be an important one on your test. So I can tell you that straight up. It's coming. It's coming for you, all right? So just know that. All right. So I hope you get a lot better score, than this on your test. Question number 4. Which type of elevator system is featured in OGGB? Computerized system control, selective collective, destination control. That's all fake news. None of these are real. Or none of these are the right answer. Okay, at least it's the number one answer. That's good. Okay, there's no way we got destination control. Those are the jobbies. If you've been downtown, you go into a nice big building, you say, I want to go to floor 31. And they'll say, go to lift number B. And you walk over there. And the concept is that they're going to, in a busy time, they're going to collect all the people that want to go to your area, maybe the same floor. They'll put you all in one lift together and make it more efficient for the lifts and for you to get there faster. Computerized system is very similar to selective collective, but it's got a lot more brains than we got in the OGGB lifts. The OGGB, it's 6 stories, plus a level 0, so 7. You don't need all that jazz. It doesn't need algorithms and trying to figure out, ooh, where's the big, demand for the lift's going to come from and try to guess which floor we should go to. It doesn't do any of that stuff. So it's simply a very simple, click the button. If the elevator is coming down and you clicked it, it will say, okay, I'll stop. I'll pick everybody up on the way down. It's your standard, very simple elevator system, selective collective. For a building that size, it's sweet. Okay. Anyway, this is where I talk about it in the slides. I won't go over it again, but there you go. All right, come on, you guys got to improve. 5 out of 8. To enhance speech privacy in an open shared office, it is best to achieve a low noise criteria, carpeting, things like that, okay? Because you want to achieve something like we have right now, nice and quiet. Is that true or false? In an open shared office. Now, for some reason, I have a feeling I'm going to get another 50-50 split here with you guys. Prove me wrong, please, prove me wrong. Did you guys watch this stuff at all? Is this the truth? You guys are still on vacation. I think that's what's going on here. Okay. For those who paid really close attention, my 33 over here, you'll know what I'm talking about. For the 73, well, what's happening in open spaces is you actually want, for speech privacy, you want a bit of white noise. You want some background noise. Because if it's dead silent and you're taking a call, it's going to be super disruptive of all the people sitting there going, what the hell is he talking about? You want noisy environments in an open space. You don't want it like you could hear a pin drop, okay? So you want very high noise criteria. You want hard surfaces. You don't want to deaden the noise in an open office space. Okay. Anyway, this is where I talk about that, all right? Open office space, quite high numbers. That's what you want. You don't want to be this guy. Oops. Oh, wait. Okay. Next. Ooh. You fell down a little bit. Okay. Back-to-back PowerPoints in a wall can enable what vocabulary word? And this is when sound evades the wall's acoustical treatments. Okay, so you do the best awesome acoustical things of the wall, insulation, all kinds of stuff. Back-to-back PowerPoints will do what? Enable an evasion, absorption, reflection, or flanking. I'm seriously worried what kind of results I'm going to get now. I have a right to worry. I think it's the same 33. 2 more people joined them. Okay, I don't know where everybody else is. I know all these words look like they could be right. Okay, it's called flanking, guys. That's what it's called. It's called flanking. All right? It's like a military maneuver. It goes around. So you put your best defense and it just outflank the defenses. Okay, so this is the slide I was talking about. The flanking in this one is when, and you have this if you guys ever, well, if you visit a lecturer up at OGGB, we have, and it's very, very common in a lot of office space, is there's no acoustical treatment at all in the ceilings. So if you have somebody who's quite loud or they're talking on the phone and you're sitting in one room next to them, you will sit there and hear most of what's being said. And that's because there might be all kinds of treatments in here, sound attenuation blankets, all kinds of, fancy pants stuff, but the sound is just bouncing over, hitting the underside of the deck and bouncing into your room because there's nothing up here. So that's flanking. Okay, flanking all of the treatments you're having here. Okay, 7 of 8. The first plaster coat in a 3-coat system is applied onto a vocab word, commonly made of expanded metal. Let's see if we get more than 35 answering this one right. Okay, is it a lath? Is it a rigid air barrier or a RAB? Is it a backup wall? Or did I make all that stuff up and it's none of these? some improvement here. That's good. Well, it's better. All right. So good old school 3-coat plaster. Don't see a lot of it these days. It's labor intensive. You got to know what you're doing. But generally, you'll use what's called an expanded metal lath. Okay, lath rhymes with math. Yeah. And so you put on the first coat, and the first coat is called a scratch coat. Nice thick layer, oozes into the gaps. Yeah, gives you a nice base to then build that plaster onto it. All right, last but not least, unlike residential broadloom carpeting over an underlay, nice soft squishy stuff, commercial carpet is usually glued down to the subfloor. Is that a true or a false statement? Let's see if you guys can all redeem yourself now. I mean, you mostly answer it right, so that's good. I don't know what happened to these 38. Okay? That is a true statement. If you ever walk around, like in a commercial building, you'll notice that it's not very nice. It's not very cushy because there's no underlay underneath there. They tend to just glue those down, and it's usually either carpet tiles or it's broadloom, but with adhesive that just goes straight down to the subfloor. That's typical. You're not out there stretching it and all that stuff. Okay. Just for kicks, let's see who won. Let's see, where's, get feedback? What's that mean? Oh, there we go. All right, good job. Not gonna throw you anything. You gotta work for it coming up. Okay. Now you guys could use whatever you want, no UPIs. Be as crazy as you'd like. If you don't like chocolate, you can leave. PIN code 203231. I'll give you a few more moments. Whale come. That's interesting. All right. Okay, 5 questions. The chilled water plant. Oh, this looks interesting. Some of these might be identical to what I asked you earlier. I don't know. I didn't have time to look, to be honest. The chilled water plant compressor changes the refrigerant from a low to high pressure liquid. I've even bold-faced the word. Now, if you guys don't get a whole bunch right here, I'm gonna be a little bit upset. The compressor compresses a vapor, okay? It doesn't become a liquid until it gets condensed, okay? So the compressor deals only with vapor. Never touches a liquid. It's okay, we'll get there. We'll get there. Good job, Santa. The component with an all-water system that conditions the air is called a or an. It just takes so long nowadays. An evaporator, cooling tower, air handling unit, or a fan coil unit. All water system. I expect great things out of you on this one. I don't know if I'd classify that as great. I really don't know how many of you guys actually watched anything. Go Sunflower. Okay, 3 out of 5. In Western cities, the most prevalent HVAC system in large buildings are what? What type of system? This was talked about in the lecture. Rooftop units for a large building, remember? VAV systems, constant air volume systems, 4-pipe, all water. Okay. I think it's the same 33, 35 people that are getting these things right. That's my guess. The rest of you, you got some studying to do. Okay, go Sunflower. Elevators account for approximately what percent of a high-rise building's energy use? So how much of an energy hog are just the lifts? A quarter of the energy, 5%, 10%, or 15%? I know jumbling up the answers doesn't make it easier. Okay, I imagine it's just going to be flatline all the same. Here we go. Oh, so much for that. You guys nailed it. How'd you get that one? You're missing some of these other ones. 5 of 5. Smoke fire, okay, is prevented from traveling through the HVAC ductwork by installing what? What do we put in our ducts? Fire safing, smoke chalking, fire dampers, none of these. All right. A few more join the club. Correct answer club. Okay, ooh, is Sunflower in the room? What about taco? Oh, this one's bare. Go. How about, I guess that's the capital Y. Good catch. And the hello girl. Ready? Oh. And none other. Good job. Oh, intercepted. Well, all righty. Okay, last but not least, tournament number 2. Okay, the pin code for this one is 959601. Some kind of, is that a goose? All right. I'll wait for 70. 70, I'm hitting it. Boom. Okay, here we go. Are you ready? I hope you are. 6 questions. Office retail interiors tend to feature more durable finishes than civic buildings, for example, museums. Is that a true or false? That's a true-false question. Is it true or false? Good job. We're getting there. Go K. 2 out of 6. In acoustics, blank is the number of pressure difference cycles that occur within a second. I know you're like, what the friggin' hell is that? Frequency, wavelength, decibels, or amplitude. Number of pressure difference cycles. That's what sound is. It's just pressure differences within a second. Man. You guys are doing much better on this one. 3 of 6. A float the floor strategy includes soft, resilient floor finishes, such as plush carpeting. Float the floor strategy. Is that true or false? Ooh. False. That's cushion the impact. That's probably splitting hairs. I won't be so evil on your test. Which is not a reason for using metal studs instead of timber studs for commercial partitions. Which is not a reason. Metal studs are not combustible. Metal studs are thinner. Partitions are non-load bearing. Metal studs are lighter. Which one of these is not a reason? Very good. Well, okay. There's the same 35. That's right. These are valid reasons. Thinner is not one of them. Okay. 5 of 6. Which type of ceiling is most common in commercial interiors? Okay, this one should be easy. Tightly attached, suspended, exposed, none of these. What was so funny about that? What kind of ceilings do you have in commercial? Man, I knew you'd do well on that one. Okay, last but not least. Fire barriers subdivide large spaces within a building into smaller fire cells. Is that true or false? If you have no idea, just guess. Excellent. Good job. All right, where's the penguin? Now you're a penguin. Okay, where is La Face Oak Booty? All right, here it goes. Oh, sorry. Where is the letter R? Okay. I'm running out of chocolates, guys. Oops, sorry. Where's niche? Uh-oh. I got bad news. Is ISPE 162 here? Would you like to come back to the office? I'll give you one if you want to come back. Otherwise, you guys split that one. Oh, wait. That's right, you said chocolates. All right, guys. I'll see you next Thursday.